In the last lesson, we learned that ESCOM produces alternating current, and that alternating current then transports from ESCOM to our house. And we said that the reason that they use alternating current is because alternating current has the ability to be stepped up and stepped down using transformers. And the reason that we do this is to minimize the amount of energy that is lost when transporting from ESCOM to our house. In one of our previous lessons, we said that alternating current looks like this. Now, if I had to ask you, what is the average current over here, we might have a little bit of a problem. Because let's say, for example, we know that this value here is 0, and let's say that the maximum current here is 10 amps, and that means that this one would be negative 10. Remember that it's negative because alternating current has the ability to go forwards and backwards. Would you agree with me that technically the average current over here is going to be 0? Because if you had to take the highest point and the lowest point and you have to try to find the average, you would say 10. Technically you would have to add them together, but that's going to become 10 minus 10, and you would divide that by 2 to find the average, but that's going to be 0. And also, it wouldn't really be correct to only use the 10 and the minus 10, because the current is not going to be 10 and minus 10 all the time. We can see that for most of the cycle, we can see that the values are going to be somewhere around here, and here, and here, and maybe somewhere here. So the average is probably, technically the average is 0, but I'm going to show you guys a different way to calculate the average. But for now, I just want you to see that we have a bit of a problem, because if you try add up the average, it's going to give you 0. Because if these parts over here are all positive, then these parts over here are all going to be the same value, but negative. And so everything just keeps cancelling out. And the same is true for voltage. If we use 10 volts, for example, and negative 10 volts, once again, if you had to do this the proper mathematical way, your average will be 0. And so what we're going to do is the following. We're rather going to look at the average AC power, because we know that power is equal to voltage multiplied by current. And when we look at power, everything's going to work out just fine, because let's say, for example, let me just call this y-axis. Let's say that this was voltage. Then I've got a graph here of current. And then let's say power. Now in the beginning, over at the start, your voltage and your current is 0. So if you had your power, that would also be 0, because it's 0 multiplied by 0. But then if we look at the voltage over here, that's 10, and we look at the current here, that's 10. So if you had to multiply them, that would give you 100. Okay, so that's going to be 100. Then we're going to get a 0 again at this point over here. So that's going to go there. But here's where it gets really cool. This voltage value is negative 10, and this current value is negative 10. If you multiply two negatives, you get a positive, and it's going to be positive 100. And so that's going to look like that. And then at the end it would be 0. And so luckily with power, we never get a negative. Power doesn't have any negatives. And so this becomes a little bit easier to find the average. To work out the average power, you literally just take the maximum value and you divide it by 2. So we can say that the maximum power is equal to, sorry, not the maximum, the average power is the maximum power divided by 2. And I just realized that up here I've got this showing. Sorry if that's bothering anyone. It says they're grade 12 calculus. Yeah. Not really appropriate for this lesson, right? So there we go. So the average power we can calculate is saying that it's the maximum power divided by 2. Then what they do is they take this maximum power, and I'm just going to write another formula for that. They know that that is I max, which is your maximum current, multiplied by your maximum voltage. You can see that over here. P is always equal to VI, so if we're using the maximum power, then that must be the current maximum and the voltage maximum. So I'm going to write out the average power, and I'm going to replace P max with I max multiplied by V max over 2. Then what they do is they decide to split the 2 up. Instead of saying 2, they rather say that that's going to be the square root of 2 multiplied by the square root of 2, because square root of 2 multiplied by square root of 2 is 2. And then they give a special name to this, and then they're going to give a special name to this one over here. And so that brings us to something called the root mean square. So if I can say IRMS, that's what they call this box. They call it IRMS is equal to the maximum current divided by the square root of 2. That's something that is given to you in the formula sheet. And then the VRMS is equal to the Vmax over the square root of 2. So they're probably not going to ask you this, but I'm just showing you how they came up with the formula. And so from now on, we can say that average power is equal to VRMS multiplied by IRMS. And so what's really nice now is we will never be able to talk about the average current or the average voltage, because we said that if you had to take the average of these graphs, it would technically cancel to 0. But what we can work out is the root mean square current, which is almost like the average. You can think of it like that. And so we could now take this graph and work out the average, but we won't call it average, we'll call it the root mean square. And that's going to give us a value of, it says that we should take the maximum, which is the top of the graph, which is 10, divided by the square root of 2. And that's going to give us 7,07 volts. So that's almost like the average. And then for the current, we could say IRMS equals to its maximum, which for this example is also 10, divided by the square root of 2. And that would also obviously give us 7.07 amps. In the next lesson, we're going to practice using the IRMS and VRMS calculations.